Hello, everyone. This is Samuel Tombwen, a student of the College of Science, Engineering, and Technology at the Grand Canyon University. This is for the course CYB 610-0500, which is Penetration Testing and Risk Management. The instructor is Dr. Howard Goodman, and today is the 15th of August 2024. So let's get on to the assignment. So this assignment, we have to use certain tools to find vulnerabilities in the Coptrix 2 virtual machine. And these tools will be Nikto, Nessus, and OWASP Zap. So let's start first of all by doing the first process of enumeration. So I turned on my Coptrix 2 machine, of course, and then my Kali machine and run a normal Nmap scan on the last octet of my IP address. Remember in the last class, we already found my IP address. So I had to do an Nmap 192.168.1.0/24. And I found my Coptrix address through method of elimination to be 192.168.1.2, as you can see right here in the screenshot. After that, I scanned the Coptrix machine using the Nmap switch P switch A 192.168.1.2. So the P and A, the switch P is for open port or port, sorry, and the A is for giving more information maybe about the operating systems and the services that are running. So I found that there was the Coptrix system. It's running on CentOS 2.0.52 and it has my SQL using OpenPort 3306 TCP. Every time I see an open port, uh, I'm curious. Maybe there's something there that we could look into. And also, there is Apache on 443 TCP. Remember, 443 is a secure port, so that looks like maybe we wouldn't have much to see in there, but we never know. Let's just go down the line. And also, there was port 22, which is SSH, secure shell, and this port can be a target for remote access for brute force attacks and unauthorized access attempts. So further down the line, um, uh, I dived into using one of the other tools called Nikto. So my Kali virtual machine is already upgraded and up to date, I use the command apt-get install Nikto. It's just a simple command, and press enter to install Nikto tools that was already installed. So it showed me that the tools were already installed in my machine, as you can see in the screenshot. And then the next task was to use the Nikto tool to scan my Coptrix 2 machine. Here we use the command Nikto switch edge uh, 192.168.1.3. Sorry, it shows 3 here, but it's supposed to be 2, just a typo mistake. So the IP in this command is my Coptrix 2 IP address. So I found several interesting information that I decided to dig a little bit further. Uh, to go into this screenshot, let's just go to the next slide and you'll see more into that screenshot, what I decided to dig further. So if you see, uh, sorry, okay, then the next tool was to utilize OWASP Zap. So I use the command apt install Zap proxy to install OWASP. And this is a little bit uh, easier than I thought. It's just a simple command. You run that and you'll be able to have Zap as an application. So OWASP Zap here is not command line as the Nikto will be. It is actually a GUI app. So GUI is a graphical user interface. So this is it. It launches like maybe like Wireshark. It has this icon with the blue and the Thunderbolt sign white. So I clicked on, I launched my OWASP Zap uh, and scan uh, my Coptrix machine by using its IP address as the URL to attack. So URL is the universal resource location. So you see right here on the screenshot, that is where I put the IP address of my Archaeopteryx, and I click on attack and then see what's happening here. Doing the scanning, bringing up several information that I could look more into. You see, so when that scanning was done, I had several inputs from which I chose to look into a few. So look, there's SQL injection here. There are two of them. There's absence of anti-CSRF tokens, two of them. In the next few slides, we'll talk about CSRF tokens. There is missing anti-clickjacking header. We'll talk about it in the next few slides. There's X content type option headers missing. So all of this is a missing and absence, SQL injection. It sound to me like they're interested. Maybe there's some vulnerabilities here. So let's take a little bit of a deeper look into this. So looking at these scans digitally, I noticed that when using the active scan, I couldn't find sitemap.xml, robots.txt. But interestingly, when using the spider, like you see in the next screenshot, you would find them sitting here pretty quiet. You see, right here, 192.168.1.2, 190 robots.txt, sitemap.xml. So that's interesting. That's what OWASP Zap, sorry, gives you. You can really dig into this and get to know more about the vulnerabilities on the system you're looking at. Okay, so let's do a little bit of a comparison on Nikto and OWASP Zap. So first of all, Nikto and OWASP Zap are both vulnerability scanner tools that can be used to scan systems to look for vulnerabilities, such as SQL injection and cross-site scripting attacks. So that's the XSS. So, but then why Nikto is more command line based, OWASP Zap is built for GUI. Like I said, GUI is graphical user interface. So it gives you a GUI experience. And then lastly, Nikto is a free or open source tool, whereas OWASP Zap is commercialized. It's a commercialized tool. Actually, the version I got that I'm using for this lab is free for OWASP, but then it has its limitation. You have to pay to get certain, further tools or plugins that you can use to dig into more vulnerabilities. So that's one of the differences between the two. I mean, you can go further and look for more, but this is just the few that I put for the sake of this assignment. Okay, so let's go back now to look at the vulnerabilities I found by using OWASP maps, or OWASP Zap, sorry. So look, still on the screenshot, I've highlighted this. I wanted, like I said earlier, let us talk about CSRF, anti-clickjacking, X content type options header missing. Let's talk about those. So clickjacking X frame options header not set. That is one of the vulnerabilities that was highlighted when I used the OWASP Zap. And it was also highlighted, if you remember, when I used the Nikto scan. Yeah, when I used the Nikto scan, we had the clickjacking X-frame, and we had X content type options header. So let's look at this. So clickjacking is a malicious technique used to trick a web user into clicking on something different from what the user perceives they are clicking on, thus potentially revealing confidential information or taking control of the computer while clicking on seemingly innocuous pages. So think of it like this: you were browsing, you're thinking that you're on Amazon trying to buy maybe a new laptop, and clickjacking is used by an attacker to fool you, to lure you into clicking on a site that you think you're clicking on a laptop on Amazon, but you're clicking on something else, and then you're giving your information to the attacker. So that's what they call clickjacking. It's actually hijacking your clicks. So the way to mitigate this attack is to configure your web server to include an X-frame options header and a CSP header with frame ancestors directive. So let's look at X content type options header not set, which is one of the vulnerabilities that I found also using using OWASP Zap and also using Nikto. So the absence of the X content type options response HTTP header may expose a website to MIME. MIME here stands for multi-purpose internet mail extensions. So it might expose a website to MIME sniffing performed by browsers when the MIME type is not explicitly declared. Can lead to the interpretation of non-executable content as executable, potentially exposing users to security risk. To mitigate this vulnerability, configure your server to send the X content type options header with the value set to non-sniff. This instructs the browsers not to and to strictly respect the declared content type. So let's look at the next vulnerability here. So I'm sorry, this is really the font is really tiny here, but this is the CSRF, which is very important. CSRF stands for cross-site request fraud or forgery. Cross-site request forgery. So this is an attack that forces authenticated users to submit a request to a web application against which they are currently authenticated. The aim of the attacker is to force the user to submit a state-changing request, such as submitting or deleting a record, or purchasing a product. So this attack exploits the trust a web application has in an authenticated user. It exploits the vulnerability in a web application if it cannot differentiate between requests generated by an individual user from a request generated by a user without their consent. Social engineering platforms are often used by attackers to perform CSRF. So looking at this, it sounds like click hijacking tool if you think about it, but then it is a little bit deeper. So let's go to cross-site scripting attacks, which is a very common vulnerability. Just give me a moment. Okay. So the XSS, which is cross-site scripting attacks, is a web security vulnerability that allows an attacker to compromise the interactions that users have with the vulnerable application. So this type of vulnerability allows an attacker to disguise as the victim user to carry out any actions that the user is able to perform and to access any of the user's data. The attack works by manipulating a vulnerable website so that it returns malicious JavaScript to users. Once the malicious code executes inside the victim's browser, the attacker can fully compromise their interaction with the application. So this type of attack can be prevented, by filtering users' input as strictly as possible based on what is exposed or valid, or what is expected, or valid input. Data on output in HTTP response should also be encoded in order to prevent it from being interpreted as active content. Okay, so let's utilize the next tool, Nessus. So first, I had to download the application from the website. So if you're using your sandbox and you're not connected to the internet, you will not be able to download this tool. So you have to switch, your network card and maybe switch from NAT to bridge, and then you're able to access the internet. And this tool is a little bit complicated to download and install, but with some research, I was able to do this and got the platform that you can see on the screenshot, which is pretty cool. So you just have to download the application, uh, create create a file, maybe using the VI editor, execute that file, and then generate a code and do an authentication, and you should be good. Pretty much, it sounds easy, but it's a little bit complicated. Okay, so after I did all of that and had my console, I clicked on the new scan button, and that gave me, see, all of these different, types of scans that I could carry out. So there's basic network scan, there's advanced scan, there's advanced dynamic scan. So this is where you see that Nesius is now is really, really cool. Let's look at the next slide here. So to perform a scan, I just click on new scan. You can't see it in this slide anyway. Click on new scan, and then you have this page. I name the scan my last name underscore Cuptrix underscore 2. I left it in the folder my scans, and then the target, very important, is my Cuptrix 2 IP address 192.168.1.2, and I click save. So when you click save, it takes you to the next page, which is on this slide, and all you have to do is click on the play button right here for the scan to run. And when you click that, for me, it took 36 minutes for the scan to complete. And when it completed, I had 2 critical vulnerabilities, 27 high vulnerabilities, 22 medium vulnerabilities, 5 low vulnerabilities, and 39 informationers. So you might have something different, but this is what I had. So I decided to dive a little bit deeper and look into these vulnerabilities. What are they? I'm curious. I really want to know. So clicking on vulnerabilities, the vulnerabilities tab, you see all the found vulnerabilities. You can choose to uh, um, align them by preference, maybe by CVSS, by VPR, by EPSS, by name, family, anyhow you want. So let's dig a little bit deeper. So I decided to explore these vulnerabilities. Like I decided to do 10 of them, but I just chose to show one screenshot. And the rest of them are similar, but different vulnerabilities. But this is what is the similar presentation you have on your console. So I didn't put screenshots for the rest 9 of them. I just put this one. So this one is PHP, which is hypertext preprocessor unsupported version detection. Sorry. So the description of this vulnerability is that the installation of PHP, which is hypertext preprocessor, on the remote host is no longer supported, which implies that no new security patches for the product will be released by the vendor. This is classified as critical. Anytime a product is no longer supported and no patches are being pushed out, it is serious. You have to, think of maybe getting new version of the product where the patches are still being sent out. So the way to mitigate this vulnerability is to upgrade a version of PHP that is currently supported. As simple as that. As simple as it sounds, let me say so. So the next vulnerabilities that we'll talk about is the CGI, which is computer generated imagery. Generic SSI server-side includes injection HTTP headers. So the remote web server hosts one or more computer-generated imagery script that fail to adequately sanitize request strings and seem to be vulnerable to an SSI, which is server-side injection, or server-side, include injection attack. So by leveraging this issue, an attacker may be able to execute arbitrary commands on the remote host. This vulnerability is rated as high. To mitigate this, disable SSI if you do not use them. Always, if you're not using a tool, not need to have it enabled. So the next one is browsable web directories. Multiple Nessus plugins found directories on the web servers that are browsable. This vulnerability falls under the CGI family and it's rated as medium. The mitigation technique to use here is to make sure that browsable directories do not leak confidential information or give access to sensitive resources. Additionally, access restrictions or disable directory indexing for any that does. There is also HTTP trace or track methods allowed. The remote web server supports the trace and or track methods. Trace and track are HTTP methods that are used to debug web server connections. This vulnerability is listed as medium. To mitigate this, disable these HTTP methods. Just disable them, and that's a simple way to mitigate. So let's look at more vulnerabilities. Web application disclosure. This vulnerability is classified as medium, and its description is that at least one web application hosted on the remote web server discloses the physical path to its directories when a malformed request is sent to it. Leaking this kind of information may help an attacker fine-tune attacks against the application and its back end. It also falls under the CGI family. To mitigate this, filter error messages containing path information. Uh, So there is PHP. We talked about PHP earlier. Uh, PHP expose underscore PHP information disclosure. This description of this vulnerability is that the PHP installed on the remote server is configured in a way that allows disclosure of potentially sensitive information to an attacker through a special URL. URL again is a universal resource locator. Such a URL triggers an Easter egg built into PHP itself. This is classified as medium. So the way the mitigation technique is in the PHP configuration file, php.ini, set the value of expose underscore PHP to off to disable this behavior. Restart this web server daemon to put the change to effect. Web server transmits clear text credentials. This is serious, but interestingly, it's classified as low. I don't know why, but it is classified as low. The remote web server contains several HTML, hypertext markup language from fields containing an input of type password, which transmits the information to a remote web server in clear text, transmitting password in clear text. That is a huge vulnerability. An attacker is dropping the traffic between web server and browser may obtain logins and password of valid users. Like I said, interestingly, this is classified as low. So let's look at, so to mitigate this, make sure that every sensitive form transmits context on HTTPS to mitigate this one. So use HTTPS instead of HTTP to mitigate that vulnerability. So web server allows password auto-completion. Again, this is classified as low. It's very interesting. The remote web server contains at least one HTML form field that has an input of type password where autocomplete is not set to off. It's similar to the one we just had before, but this is not about clear text, but it's about autocomplete of password. So like you start typing an email address and then it prompts you that do you want to autocomplete, and you click on yes, it gives you the cached password. As a serious vulnerability. This does not represent a risk to this web server per se, but it does mean that users who use the affected forms may have their credentials saved in their browsers, that's cache, which could in turn lead to a loss of confidentiality if any of them use a shared host or if their machine is compromised at some point. To mitigate this, add the attribute autocomplete equal to off to this field to prevent browsers from caching credentials. So the Apache HTTP server version, this is actually informational, but it can be used as a vulnerability. The remote host is running the Apache HTTP server, an open source web server. It was possible to read the version number from the banner. This could become a vulnerability as such information could be exploited using Nmap and Metasploit as we did for Cuptrix One Machine. I hope you remember that. So flow hypothesis methodology. First of all, this is a system analysis and penetration technique in which the specification and documentation for an information system are analyzed to produce a list of hypothetical flaws. This list is prioritized on the basis of estimated probability that a flaw exists on the case of exploiting it, on the ease of exploiting it, and the extent of control or compromise it will provide. Based on my findings using Nikto, OWASP, and Netshoes, I have hypothesized that there are several flaws in the Cuptrix 2 machine, and most of them are web-related. This could be the case because the tools mentioned above are used to scan for web vulnerabilities. That's true. The screenshot below shows the output when using Nikto to scan Cuptrix 2. It shows hypothetical flaws such as anti-click jacking and X-content type options header not set. Remember we talked about those earlier? These are them here highlighted. This is me using Nikto to scan my Cuptrix. Let's go to the next slide. Okay, so let's look at vulnerability analysis and mapping. So I'm looking at Apache 2.0.52. I'm mapping to the vulnerability that the current version is at least 2.4.54. If you look closely in this screenshot, you will see that the current version, the version on the server is 2.0.52, but the current version is at least 2.4.54. Another is anti-click jacking. The vulnerability here is that the xrem options header is not present. So another is the target port, port 80. Remember, it runs on protocol HTTP, which is not secured. So the vulnerability that I mapped to this is unencrypted. It is unencrypted because it is a default port for HTTP. It is insecure and can be used for distributed denial of service attack. So let's look at certain tools and techniques. So doing some research on the Apache 2.05, 2.0.52, I found that the AP underscore arrowwrite function, there's a function Apache in Apache HTTP server 2.4.53 and earlier. So if it's not later than 2.4.53, may read unintended memory if an attacker can cause the server to reflect very large input using AP underscore write or AP underscore arrow put. This attack is described as read beyond bounds via AP arrow write. And the attack vectors, hypothesis, and root cause. So using this vulnerability, the Apache vulnerability, the attack vector I would hypothesize using is XSS, that's a cross-section scripting, since it allows the attacker to compromise the interaction, of users have with a vulnerable application. So the root cause of this vulnerability is the version of Apache HTTPD installed on the remote host is prior to 2.4.54, which is therefore affected by multiple vulnerabilities. DDoS is also a vector that uses port 80 to overwhelm the server and render it unavailable to intended users. So this can be mitigated by using port 443. Let's look at the next slide, which I think is the last. So recommendations for vulnerability disclosure. First of all, there are two types of disclosure. There's responsible disclosure and there's full disclosure. Responsible disclosure is kind of disclosure where the group reporting the vulnerability contacts the party responsible for the affected system, software, or network. Under this procedure, researchers provide a timeline to investigate and fix the vulnerability. Once the patch is implemented, the vulnerability is publicly disclosed. Full disclosure, this is publishing information on vulnerabilities without restriction as early as possible, making information accessible to the general public without restriction. So we've come to the end of this one. It was quite a long one. Let's just look at the references. Thank you for watching. I hope you have a blessed day.